Hello, algebra students. Well, today we're going to divide more polynomials. The other day, in the last video, we divided a polynomial by a monomial. And that's a simpler case than we're going to look at today. These today will be a polynomial by a binomial. So we're dividing by something that's it's not going to be as simple. So here's the examples we'll be doing. And to do this, we use something called polynomial long division. And this is a more complex process, but it's very similar to the familiar long division that we learned in grade school. So first, let's look at a couple of examples of long division, with regular long division, to refresh our memory how it works. Polynomial long division works much the same way. So we have here 10,535 divided by 5. So probably been a while since you've done this. You say, how many times does the 5 go into the 1? We start at the very first digit, and of course it doesn't go into 1. So we go ahead and say, okay, 10. We'll say, how many times does it go into 10? Taking the first two digits. And it goes 2 times. So we write the 2 up there, and then we take that 2 times 5, and that's 10, right? And the 10 we write down here. And then we subtract. We get 0. We bring down this 5. We say, how many times does 5 go into that? Well, 1 time. So then 1 times 5, multiply that, and we get 5. We subtract it, gives us 0, and we bring down the next digit, which is 3. And then we say, how many times does 5 go into that? Well, it doesn't go at all. So we write down 0 and take 0 times 5 and write it down here. Subtract, bring down the last digit, which is 5. And how many times does 5 go into 35? Well, 7. Then take that 7 times the 5. We get 35. And we're out of digits to bring down, so we're done. This 0 is the remainder, so there's no remainder. It divides in evenly. So that's it. Okay, so let's look at one more. 4,356 divided by 7. The 7 does not go into 4 at all, so we go on and say, well, how many times does it go into 43? Goes 6 times. 6 times 7 is 42. Subtract. We get 1. Should have went ahead and wrote a minus sign here, I guess, really, and here. So bring down the 5. 7 goes 2 times. 2 times 7 is 14. Subtract, you get 1, and bring down the 6, and 7 goes into 16 twice. 2 times 7 is 14. Subtract, we get 2. And that is the remainder because there's nothing left to bring down. So this time it doesn't go in evenly. There is a remainder. So we write R2 up here, meaning remainder 2, or the answer can be written 622, and that 2 means you also have 2 sevenths. Okay, 622 and 2 sevenths. The 7 coming from, what we're dividing by. Okay, so that's long division. So now let's do this with polynomials. So let's look at this first one. I'm going to write it down over here so I have a little bit more room. We write this out in a long division form, just like with numbers. Dividing by x plus 3. So we say, how many times does that thing we're dividing by, the x plus 3, how many times does that go into the x squared? We just look at that first term. And we don't really have to worry about the 3. We ignore that. We're really just looking at the x. How many times does x go into x squared? And it goes in x times. And what that really means is that x times x here, multiplying those two together, is going to give us the x squared. Okay? That's what we're looking for. A number to write on the top that we can take times this x to get that. Okay? So, think about it, and that is x. So now we go ahead and we do that multiplication, and this is just like with the numbers. Like, look at our first division, okay, over here. We found 2. We used 2 because 2 times 5 would give us the 10, would give us this 10 that's in here. 2 times 5 is 10. That's why we chose 2. Okay, so this times it's x. And so now we go ahead and do that multiplication, x times the x plus 3. We multiply it by the entire thing, x plus 3. So x times x is x squared. X times 3 is 3x plus 3x. Okay, and now we subtract that, and I think an easy way to write it is that's similar to the way we wrote it in the long division. We'll just put parentheses around that, and we'll say we're subtracting it. Okay? So let's do that term by term. The x squared minus x squared. So I'm taking, this minus that. And that's 0. Now we have to take this negative 3x here minus the 3x. Remember, we're subtracting. This minus sign, the minus sign out there is distributed through the whole thing. Okay? So that's the negative 3x that we have up here minus 3x. So that's negative 6x, right? And this is, you have to be careful with this part. Just think about what you're doing. So we bring down the negative 48 from up here. Bring that down. Okay? So now we say, well, okay, how many times does this x out here, again, we sort of just ignore the plus 3 part. How many times does x go into this? And it's going to be negative 6. Oh, I wrote down this problem wrong. Yeah, okay, let's fix it. This should have been a 13 here. So back up a little. Sorry about that. This is negative 16. So I'll fix that. You guys probably caught that mistake, right? Okay. So we actually have negative 13x, there it is, minus that 3x. So that's minus 16x. And then we brought down, again, the negative 48 to here. Okay, so now, backing up, we want to see how many times does this x go into negative 16x. We want a number that when we multiply it by the x, we get negative 16x. And that is negative 16. The nice thing about this is if you pick the wrong number, you're going to find out. If you write down the wrong thing on top, you're going to find out. Because the next step is to multiply that negative 16 that we just wrote times the x plus 3, times the whole thing. So negative 16 times x is negative 16x. And negative 16 times 3 is negative 48. And, you know, this and this should be the same. That was the point. If they're not, we made a mistake. They are. So we're going to now subtract that whole thing. Okay. So this gets a little tedious, but think through it. If you want, you can say, okay, we're subtracting a negative, so that turns into a positive. We're subtracting that, so that's positive. But you have to realize if you do that, now we are adding everything, right? So whether you want to change it in the way you write or just think about it, that's up to you. I'm going to leave it like this time. Play it straight. I multiplied negative 16 times x plus 3, and I got this. And now I'm subtracting that. So I say, okay, negative 16 minus the negative 16, that's negative 16 plus 16. So that is 0, just like we wanted. Now we have negative 48 minus a negative 48. Well, that's negative 48 plus 48. That's 0. And we know that this is going to be 0, right? 0 plus 0, because when we got this, it was the same as what was right above it. So we're subtracting something from itself. Okay, so there's no remainder this time. That's it. We're done. There's nothing left to bring down, so we have our answer, x minus 16. Okay? Well, one example is never enough, and some of that might have looked a little mysterious. I'm not sure about that, but look at a couple more examples. It will get more and more clear. Okay, so the next one, we'll write this down correctly this time. I won't make that copying error. So we have x cubed plus 5x squared minus 3x minus 1. I think I wrote it down correctly. And that's divided by x minus 1. Okay. So how many times does this x go into the x cubed? And again, it's whatever we write down. When we multiply it by the x, we want to get back x cubed. So it's x squared. So x squared times x minus 1, multiply it by the whole thing. That's x cubed minus x squared. Okay, and again, we are subtracting that. We know it's right because we did get x cubed when we multiplied it back, right? We got this x cubed just like we wanted to. So we subtract. So the x cubed minus the x cubed is 0. 5x squared minus a negative x squared. That's 6x squared, right? Okay. And then we bring down minus 3x. We say, how many times does x go into that? That's 6x. Multiply that 6x times our x minus 1. That's 6x squared minus 6x. This matches this, so we did it right. Subtract that. 6x squared minus 6x squared is 0, like it should be. Negative 3x minus negative 3x. That's negative 3x. I'm sorry. Negative 3x minus negative 6x. And remember, this minus out here is why it's negative 3x minus a negative 6x. So that's negative 3x plus 6x, right? And that is 3x. So we bring down negative 1. And we say, how many times does this x minus 1 go into that? Specifically, we're really just looking at the x, and it's 3. So we write plus 3. We multiply it. 3 times x minus 1 is 3x minus 3. We're going to subtract that. And 3x minus 3x is 0. The negative 1 minus a negative 3, that's negative 1 plus 3. And we get 2. Okay, so, or 0 plus 2 we could write. There's nothing left to bring down, so we're done. This time it didn't come out to 0 down there, right? That's the, on the first one, we got 0 right here. And so there was no remainder, and that was just our answer. This time we do have a remainder because we have this 2 at the bottom. So we could write it like this: remainder 2, and that's our answer up there on top. Or we could write it, I'll have to sort of squeeze it in here, x squared plus 6x plus 3, and the 2 that's left over is the numerator, and we have to say plus that 2 over the x minus 1, okay, which is here. That's like with regular division, it was 7 in that problem. Remember, we had a remainder. This example right here, right? So we took the 2 divided by 7 because of that 7. Okay. So you could either, those are the two ways of writing it. Two ways of writing the answer. Okay, one more. And let's see if I'm gonna probably move this up a little bit to make sure I have room. So this will be a little bit crowded, but it'll be fine. I'll move this up. And that way I can write the problem down below it. So here's our division problem. Whoops. Two x cubed plus x squared minus 8x minus 4, and we're dividing by x plus 2. Okay, so write that a little better. We say, how many times does that x go into 2x cubed? Well, this time it's not just x, it's going to be 2 times something, right? 2x squared should work. So we write the 2x squared, and then we multiply that by the x plus 2, and so 2x squared times x is 2x cubed. Okay, it matches what's right above it, so that's good. 2x squared times 2 is 4x squared. Okay, so we are subtracting that. The 2x cubed minus 2x cubed is 0, and then we have the x squared minus 4x squared. So that is negative 3x squared. And I'm going to have to be aware of writing this a little bit higher so I don't run out of room. Bring down the 8x. Okay, so now how many times does x go into the 3x squared is what we're looking at. I'm sorry, the negative 3x squared. So it's negative 3x is what will work, because when we multiply that back, we'll get what we want. So negative 3x times x, negative 3x squared. Okay, and negative 3x times 2 is negative 6x. Subtract that. We get our 0 like we wanted to for the x squared part, and then we have negative 8x minus a negative 6x. That's negative 8x plus 6x, negative 2x. And we have one more thing to bring down, the 4. So how many times does x go into that? Negative 2, right? A negative 2, now multiply it, negative 2 times x plus 2. Negative 2 times x, negative 2x, negative 2 times 2, negative 4. How about that? It's the same. They're both the same. It's going to just go to 0 plus 0, right? So no remainder this time. And so this is our answer right up here. Okay? So that is polynomial long division. Just a quick note, something I didn't mention was make sure when you write these down, when you write the long division out, the big polynomial has to be in descending order. Okay, so you can't mix those up. They have to be in descending order by the exponents. Sorry, that's what I mean. So in this last example, for example, 2x cubed plus x squared minus 8x minus 4. It has to be in that order. The exponents go down. First one has an exponent of 3, then 2, then 1. Okay, they have to go in that order. Okay, so that is all for now.